Hello, welcome to Chapter 5, homework questions 89 through 95. Question 89, Lizzie noticed that two angles of triangle DEF shown below have the same measure. Based on this information, what statement can you make about the relationship between line segment DE and line segment EF? So once again, based on the information, what can we make? Well, we notice that the angles are both 54 degrees, which means the triangle is an isosceles triangle. And if that's the case, then the side lengths across from both of those angles should also be the same length as well. Their measure should be. So therefore, we know that the length of DE, and you don't put the line above it because we're talking about the measure, is equal to the length of EF. Because it is an isosceles triangle, knowing that these two angles are congruent makes the sides opposite them congruent and makes their measures equal. So we could say DE is equal to EF. We could also say line segment DE is congruent to line segment EF. So that's the difference between not the line and having the line. With the line, it's congruent. Without the line, we're talking about the measure. Question 90. Find the length of DF in the diagram from problem 5-89 if DE is equal to 9 millimeters. So I don't think that needs to be there because we're talking about the measure. So DE is 9 millimeters, which means EF is 9 millimeters, but we're looking for DF, which is down here. We'll probably need to use law of sine since it's not a right triangle. We do need to figure out what angle E is, and we can do that by taking 180. So if we take 180 degrees minus 54 degrees minus 54 degrees, that'll give us an angle of 72 degrees, and we'll just call line segment measure DFX. So let's use our law of sines. We can say sine of 54 degrees over the side opposite that, which is 9, is equal to sine of 72 degrees, and the side opposite that is the unknown, which we don't know, so we'll just call that x. We can solve for x by multiplying by 9x to both sides or cross multiplying. This will give us x times sine of 54 degrees is equal to 9 times sine of 72 degrees. You can divide both sides by sine of 54 degrees. And then you really can just plug that whole thing in your calculator. If you want to include parentheses on the top, you can, but it'll do order of operations for you. So if you take 9 times, we got sine of 72, and divide that by sine of 54 degrees, you'll get approximately 10.6. So therefore, DF is going to be approximately, 10.6, and make sure you label millimeters. Question 91, find the area of the triangle below. Show all your work. So to be able to find the area, we need to be able to find the height of the triangle. And we can do that. We have 30 degrees. We can use our right triangle to figure out what the height is. And let's go ahead and do that. And I guess we know it's a 30, 60, 90 triangle, so that even helps out. We can use our shortcuts if you remember them. If not, no big deal. But the shorter side should be half the hypotenuse, which is 6. So that gives us the height, which is perfect. So we can find the area. That is 1/2 times the base times the height of the triangle. And if you multiply that, you should get 72, and that will be units squared. If you were able to get to question 87 in the core problems with your team, there is another formula that was learned on question 87, and it's the area is equal to 1/2 times the side length times the other side length, but it has to be the sine of the included angle. So it has to be side angle side, but the included angle. Once again, only use this if you did do question 87 and you were able to go through and make sense of it. But it is another way that I just wanted to make sure that I covered in case anyone was able to get to question 87. Question 92. In the diagram below, triangle ABC and triangle ADE are similar. if line segment AB has a measure of 5 and line segment BD has a measure of 4 and BC has a measure of 7, then what is the measure of DE? So since we know they are similar, let's go ahead and mark the figure to what we know. Since we know the triangles are similar and we have the measures written down now, we'll go ahead and write our proportions. AB, so that's 5, is to the whole length AD, and that's 9. And that's equal to the length of BC, 7, to the length of DE. And that's our unknown. And so when we solve, that's 63 is equal to 5x. X is equal to 12.6 units. So the measure of DE equals 12.6. Question 93. Stefan does not like yogurt very much, but he loves apples. Since both make a good snack, Stefan's mom makes a deal with Stefan. She will keep the refrigerator stocked with 5 yogurts, 2 green apples, and 3 red apples every day. Each day, Stefan will randomly pick a snack. What is the probability that he will not get 3 yogurts on 3 consecutive days? Use a tree diagram or an area model to show all the possible outcomes in the sample space. So figure out, which model you want to use, the tree diagram or the area model, and then we'll go from there. So in this example, because there's 3 choices, the area model is not going to be practical for this. So we're going to go with the tree diagram. I've already started it. The first 3, the yogurt, the green apple, the red apple, and then I did it again from the yogurt, green apple, red apple, and then one more time for the 3 different choices, and then I didn't extend the rest. But as you're reading the question, it says, what is the probability Stefan will not get 3 yogurts on 3 consecutive days? So to get 3 yogurts on 3 consecutive days, you have 5 tenths times 5 tenths times 5 tenths, which would be 125 over 1,000, or 12.5%. So to get a yogurt on 3 consecutive days would be 12.5%. So to not get one, we can take 100% and subtract the 12.5%, and then that will give us 87.5% that he would not get a yogurt 3 consecutive days. Question 94. Solve each equation below for x. Check your solution if possible. Alright, let's start with A. We have 4/5 x minus 2 equals 7, so we can add 2 to both sides. That will give us 4/5 x equals 9, and then we can multiply by 5/4. You could divide by 4/5 either way and get x is equal to 45 over 4. And if you want, you can simplify that to decimal form, 11.25. And then to check your answer, you're just going to take that and plug it back in. So to check, it would be 4/5 times 11.25 minus 2 equals 7, and it does check. On to B. We have an x squared, but we can isolate it by dividing by 3 and get x squared equals 100. And then when you take the square root, you get x equals 10. But also remember, it's really when you take the square root, it's the absolute value of x that equals 10. So you get 2 solutions, negative 10 and 10. And then same thing when you go to check your solutions, it's just 3 times negative 10 squared equals 300. And that works. And 3 times positive 10 squared equals 300. And that is also correct. So it does check. On to C. Let me rewrite this one. This is 4x minus 1 over 2 is equal to x plus 5 over 3. We can multiply both sides by 6. You can cross multiply if you want as well. Works out the same way. You're going to get 2 times x plus 5. And this is equal to 3 times 4x minus 1. And then you can distribute 2x plus 10. And then the right side is 12x minus 3. I'm going to subtract 2x. 10 is equal to 10x minus 3. Let's go ahead and add 3. That would be 13 equals 10x. Divide by 10. And x is equal to 1.3. And to check that, once again, you're just going to plug that right back in to 4 times 1.3 minus 1 over 2. And we want that to equal 1.3 plus 5 over 2. That was over 1.3 plus 5 over 3. And when you plug both of those in, both sides equal 2.1. So it does check. And the last one, D, we have a quadratic. X squared minus 4x plus 6 equals 0. You could use the quadratic formula. Completing the square would also be a possibility here. And potentially factoring as well. It does appear that factoring will not work on this example, so we're going to have to choose one of our other methods. Maybe this is a good time to show completing the square as a review, so I'll do that instead of the quadratic formula. So when we complete the square, remember we are trying to figure out what we need to, our middle term, minus 4x, because we know that we're trying to create a square here, and since we need to break that up into 2 equal parts, that would be minus 2 and minus 2. And then what do we need to add to complete our square? We need a positive 4. Well, right now we have a plus 6, so we actually need to take 2 away to complete our square, and then we'll have x minus 2 squared equals negative 2. And then we're ready to go in terms of solving it by working backwards and taking the square root. But what we're going to notice is we're getting ready to take the square root of a negative 2. And since we can't take the square root of a negative 2 to get a real number, there are no, and maybe I should throw in the word real, there are no real solutions to this problem. Same thing would have happened with the quadratic formula. You would have plugged in the opposite of b, plus or minus the square root of b squared minus 4ac. And when you do the b squared, that would be 16 minus 4 times a times c. You'll notice you would have got 16 minus 24, which is negative 8. And then you go to take the square root, and you still are going to run into that problem. So on part D, there is no real solution. Question 95. Solve the system of equations below. Write your solution as a point in ordered pair form, and then check your solution. So I'm going to go ahead and use substitution. Since y is already solved for, we're just going to replace the y in the second equation with the expression, well, if I can write a 5, with the expression negative 3x minus 2 is equal to 16. Go ahead and distribute the 5 to get negative 15x minus 10 equals 16. Combine your like terms. I'm also going to add 10 to the other side to get 26. Divide by negative 13. And x is equal to negative 2. And then I can take that, plug it back into the first equation for x, and solve for y. 6 minus 2 is 4. So the solution is negative 2, 4. That means that's where the two lines intersect. That's the point that they share in common. To check our solution, we're just going to plug them back into both equations, and we really just did for the first one, but I'll do it again. 4 is equal to negative 3 times negative 2 minus 2. So 4 is equal to 6 minus 2, or 4 is equal to 4. So that checks. And then the second equation, 2 times negative 2 plus 5 times 4 equals 16. That's negative 4 plus 20 equals 16, and 16 is equal to 16. So that one checks as well. So if you're going to check your solution, you do need to plug it in to both sets of equations to check that it works for both of them.